Okay, so hi everyone, thanks for coming. I'm Germán Martínez and I'm working in the CLaSP department. As Kawe said, I'm team member of the current Mars Science Laboratory mission, and I'm co-principal investigator of the next Mars 20 and 20 mission. And today I'll be very briefly talking about the exploration of Mars. Do you have any estimation of how many missions have been sent to Mars? Like, could you give me a number? Any of you would dare? Overall number of missions? 30. Okay, I mean, the order of magnitude is there. Okay, here we have like the portrait of the Mars family. So overall, 43 missions have been sent to Mars, exactly from 7 different countries or institutions. So the first mission sent to Mars ever was by the former USSR, obviously the US, then like Russia currently, Japan, and the European Space Agency in 2003, and finally the Indian orbiter 2 years ago. And so out of these 43 missions sent to Mars, do you have an estimation of the percentage of success? So exactly the number is 47%. So pretty much like 53% of the missions sent to Mars failed, but I guess that the good news is that over the last 10 years, this percentage of success raised to 90%. So obviously we are doing much better. So it's pretty comforting. Let me tell you some milestones about the exploration of Mars. So, sorry for this, you cannot read, but in 1964 here, the Mariner 4 flyby mission returned the first picture of the surface of Mars. Then in 1971, the Mariner 9 was the first probe to orbit Mars ever. The Viking landers in 1975 were the first 2 landers successfully landed on the surface of Mars. Although I have to say that in 1971, the USSR successfully landed a lander at the surface of Mars, but unfortunately, after 15 or 20 seconds, it stopped communication. So the Viking landers were the first landers that operated like for a long time. A little bit more of history here. Since 1975 till 1992, there were like 17, 18 years where the US didn't send any mission to Mars. So that means that basically the decade of the 80s was not like the best one in terms of Martian research. There was only this like Russian mission in 1988, if I will remember, that was sent to Mars. And then starting in the early or middle 90s, the exploration of Mars is or has come to life again. Okay, so we are sending mission to Mars. What is the objective? Why are we sending mission to Mars? The question defining the exploration of Mars is there life on Mars? So we all agree that if the ultimate goal is to look for life on Mars, it makes a lot of sense to start following the water. Here on Earth, pretty much where we find water, we also find life. So let's start like following the water. That happened until 2009 with the Phoenix mission, and currently the Curiosity, the Mars Science Laboratory, has marked the transition between follow the water and seeking signs of life. So the main objective of the Curiosity rover is to determine the habitability of Gale Crater, so the landing site. Then for the next 5 years, we have guaranteed the exploration of Mars. So we have like the next NASA lander called InSight in 2016. Then we have 2 additional rovers, the 2018 ExoMars rover by the European Space Agency, and the Mars 20 and 20 rover, and also the this orbiter in 2016. So the Mars exploration should be guaranteed, looking better than in the 80s and also 90s, I guess. Okay, so let's talk about the current Curiosity rover more in detail. What you can see here, this is the mast of the Curiosity rover. As you know, that's the name for the Mars Science Laboratory rover. In particular, what you see here is the meteorological station aboard this rover, which is called REMS, Rover Environmental Monitoring Station. I'm bringing this up because what I'm doing currently for the mission is to analyze the environmental measurements by this station. And it's also quite important to me because the former principal investigator of the mission was my PhD advisor more than 10 years ago. So pretty much the reason for which I'm here is because of this meteorological station here. Talking about the science that this is doing, it's measuring the ground temperature, air temperature, pressure, relative humidity, UV radiation at the surface of Mars for the first time, and wind speed. So, I mean, like a meteorological station. Not much of a mystery. Here we go to the Mars 20 and 20. What I'm showing here is the payload for the Mars 20 and 20 NASA mission, and 7 instruments were selected for this mission. And one of them is called the Mars Environmental Data Analyzer, and this is meteorological station that will be the meteorological station aboard this rover. As you can see, it's a contribution from Spain, and I am the co-principal investigator of this instrument here, and I'm particularly helping in the development of a thermal infrared sensor that will measure, or that will help measure for the first time, the surface energy budget of Mars. It's a Spanish contribution, as you can guess because of my accent, I guess. I'm also a Spaniard, so I have like a close collaboration with the guys in Madrid. The PI in Madrid I closely collaborate with him. Some other instruments aboard the Mars 20 and 20 rover. We have here the SHEDLOG, which is like a Raman spectrometer to try to detect organic compounds. That would be the first UV Raman spectrometer on Mars. Then we have a cool instrument here, MOXIE. This instrument will produce oxygen out of the CO2 Martian atmosphere, which is quite important for future manned mission, as you can imagine. And then we have like high-resolution cameras, SuperCam, and what was the other? Mastcam Z. We have a penetrating radar, which is contributed by the Norwegians, and 7 instruments overall. So what do we have here? Okay, now I'm gonna give like some simple examples of how planetary science will help us survive on Mars at some point. I'm pretty sure that most of you watched the movie. I have to recognize, I admit that I went to the cinema yesterday to watch the movie, so I did my homework. So I'll be ready for your questions. Okay, so what I'm showing here, these are real data coming from Gate Radar. What I'm showing in the figure on the left is the ground temperature measured by the Curiosity rover, and it's expressed in degrees Fahrenheit as a function of the Sol number. As you remember, a Sol on Mars is just a Martian day, which lasts 24 hours and 37 minutes. So far, as you can see here, the rover has been operating for more than 1,000 sols, so that pretty much makes like, close to 3 Earth years. And let me focus on a single Sol. Like, for example, follow this vertical line on Sol 700. What we can see here is that over the course of the day, around noon, the temperature is, let's say, pleasant. It's like 50 Fahrenheit. So that's like a bearable temperature. But that same day, and this is something that doesn't happen on Earth, that same day, but at, let's say, 5 or 6 a.m., which is the coldest time of the day on Mars, the ground temperature falls down to minus 120 Fahrenheit. So the diurnal amplitude in temperature on Mars is, like quite huge and crazy. Here on the right, I'm showing also atmospheric pressure measurements by the rover. And what you can see here is that the atmospheric pressure on Mars is like around 1% of the atmospheric pressure on Earth. So it's just like 0.1 psi, which means that the Martian atmosphere is, like much, much thinner than the terrestrial one. Also, what you can see here is that the pressure repeats after 1 year. Basically, at the end of the winter, we start with the spring again, and we will have another M like over the second year. If you wonder why we have like this up and downs in pressure, this is due to the deposition of CO2 gas. So basically, in winter time, when the temperatures are really low, the atmospheric CO2 gas deposits on the surface. It becomes like dry ice. And then when temperatures start rising, that CO2 ice sublimates and again like replenishes the atmosphere. So then we have another like increase in the pressure. So, okay, what do we have here? This is again like as a function of the number of Martian days since landing. We have the maximum relative humidity at 1.6 meters. So one of the instruments aboard the mission was a hygrometer, okay, that was measuring the relative humidity. What you can see here is that the relative humidity in the air never reached 100%, which means that at equatorial latitudes we don't have fog formation. A different thing is at the ground, because the ground might be much colder than the air. But in the air, we see that we have maximum relative humidities of only about 62%. So that's pretty dry. And I have to say that at northern or like more polar latitudes, the atmospheric relative humidity can be 100%. Indeed, in the 2008 mission to the North Pole of Mars, the relative humidity exceeded 100%, so we had fogs. Indeed, like snowfall was even recorded at the North Pole of Mars. That was 2009, the Phoenix mission. Okay, and this is the last slide. I'm sorry because I think I only had 5 minutes and I'm going beyond limits. Anyway, this is the potential landing site candidates for the Mars 20 and 20 mission. And as you can see here, they have been narrowed down to 8 candidates. All of them within the range of latitude plus minus 30. I guess the most important thing, like for the selection of candidates, this is a process that is open to the entire science community. So don't think that you have to be part of this to have a say. Basically, everyone can have a say here. So obviously, all these 8 candidates must meet all the engineering requirements. So absolutely all of them engineering requirements. And obviously, they must make sense when it comes to the science. So for example, the Mars 20 and 20 main objective is to determine the habitability of Mars. So obviously, the candidates, the landing sites have to be places where the potential for the biosignature preservation is really high, because that's what we want to detect, or that's what we want to analyze. So basically, it has to be like not a compromise. It has to meet all the engineering requirements, and it has to be a cool place to achieve the science that has been stated. And I think this is it, and I'll be happy to answer your questions later. Thank you very much.